is asked in 2006 for 2 marks. This is quite easy one. Mm. So he's asking what is the omega max by omega mean. We already know that coefficient of fluctuation of energy equal to omega 1 minus omega 2 by omega 1 plus omega 2 divided by 2. Here omega 1 is omega max and omega 2 equal to omega minimum. So here omega 1 equal to omega max. We substitute this omega at the end. Omega 2 equal to omega minimum. And so if you um, take this 2 to this side, and I will write like this. I am taking entire this term into this side and CF to this side. So it will become omega 1 minus omega 2 in the denominator, and this is 2 by CF, and I will add this is numerator and this is denominator. So on the both side I will add denominator to the numerator, and then I will subtract denominator from the numerator. So that is n plus d by n minus d. So this is the n, this whole term is n, this whole term is denominator. So this is the numerator. So this will become 2 omega 1 by, if you subtract this one from this in numerator, it will become 2 omega 2. Here this is 2 plus CF by 2 minus CF. So finally this implies omega max by omega minimum equal to 2 plus CF by 2 minus CF. So very easy problem. The speed of an engine varies from 210 to 190. So this is the maximum speed and this is the minimum speed during a cycle, and change in kinetic energy is found to be 400 Newton meter. That's a joule. The inertia of the flywheel. So it's again direct problem. So we know delta E equal to half into I omega 1 square minus omega 2 square. So he is asking I. What is the I? 2 delta E by omega 1 square minus omega 2 square. So if you observe, all these problems are based on only those 4 or 5 formulas. So always it's easy to fetch a marks in the flywheels. So 2 into 400 divided by 210 square minus 190 square, then we will get approximately 0.1. Answer is A. And next problem asked in 2013 for 2 marks. Let's read the problem. A flywheel connected to a punching machine, and supply energy 400 Newton meter. And so far we haven't seen what is a punching machine, but in actually a punching machine, what happens is a flywheel is connected to the punching machine, so that deficit energy will be provided from the flywheel. That means the energy whichever provided by the flywheel is the deficit energy, that is in turn is a fluctuation of energy. So the energy provided by the flywheel is nothing but fluctuation energy in the punching machine. So here they have given um, flywheel is connected to the punching machine and supplying energy this much. That means this is the what is that fluctuation of energy, that is 400 joules while running at a mean angular speed 20. So they have given mean angular speed omega, that is 20 radian per second, and then if the total fluctuation of speed is not to exceed 2%, yes, here we got this one. So total fluctuation of speed is not to exceed plus or minus 2%. So in the previous case, we already discussed what does it mean. So plus or minus 2% means, for example, if omega is the mean fluctuation of energy and omega 1 is 1 plus 0.02 of omega, that means 0.02 of omega, and omega 2, that is minimum angular velocity, equal to 1 minus 0.02, that becomes 0.98. So if you subtract this omega 1 minus omega 2, that is the fluctuation of energy, it becomes 0.04 omega. That's what it's mentioned here. It shouldn't exceed plus or minus 2%. If you plus 1 and a negative 1, if you take plus 1 and negative 1, that becomes 0.04%. 0.4%, that is a 0.04% of the mean value. So this is what it's a meaning. And so we from this we can calculate Cs equal to omega 1 minus omega 2 by omega, that is 0.04. And in the previous case, instead of giving plus or minus 2%, he has given total fluctuation of energy is 2% of, just 2% of mean speed. He didn't mention it's a plus or minus 2. That's why in that case we there we have taken, if you remember, we have taken delta n equal to 2% of n. But if it is a plus or minus, then we need to consider like this. Okay, so let's forget about this one. And we have this one also. We have mean angular velocity. Again, we need to calculate moment of inertia of the flywheel. So delta E, again delta E equal to I omega square Cs, and I equal to delta E by omega square Cs. If I directly substitute the values, 400 by omega square equal to 20 square into 0.04. So what is this value? This we get approximately 25. What is this? kg meter square. Always we need to remember what are the units that we are substituting in the formula. So even if you know the entire procedure and formula and the concept, everything, but sometimes we may end up with the wrong answer. That's because of the wrong substitution of the units. For example, here Newton meter, instead of it is a kilonewton meter, and if you forget to substitute 1000 in the delta E, then it's gone. Your problem will be wrong, even though you know concept very well. So while doing all these problems, we should be very thorough and careful about the unit substitution. In 2014 for 2 marks. Let's read the problem. So they have given flywheel mass is a m, which is distributed equally. So this is equally distributed between a heavy ring-like rim of radius r and a concentric disc-like feature of radius r by 2. So if I draw the flywheel diagram, this is like this, and we have a ring part. This is the outside ring, and we have a disc. This green color is the disc one. This disc is fitted in the ring. A ring is a blue color one. So let me draw blue lines for that one. And this is the ring. Actually this thickness is not this much, but for the sake of understanding I have drawn this much thickness, but in reality this thickness is much more neglected. I mean, this, if consider T as this one, and T is almost neglected. And heavy ring like rim. So this is the rim, and he also mentioned like a radius of the ring. For example, this is the rim radius, that is given as a r, and this disk radius also given as a r by 2. For example, this is the O point, and mass of this disk is or ring is m by 2, and mass of this disk is m by 2. So we need to calculate moment of inertia for this one. So what is the moment of inertia for the, first we calculate moment of inertia for the ring. So what is the moment of inertia for the ring? Mr square. So here mass of the ring is m by 2 because it's equally distributed, and here r is r, mr square, plus what is the mass of this is the moment of inertia for the ring r, and this is, and the next one is mr square by 2, that is for the solid disk. Here m equal to m by 2 because it is equally distributed, and here r is r by 2. So and by 2, and this is moment of inertia for the solid disk SD, and this moment of inertia of the moment of inertia of the entire body that is passing through the point O is simply the addition of moment of inertia of the ring plus moment of inertia of the solid disk, because they are coincident and passing through the same point. Or if the point is not coincident of the two centers of the bodies, then we need to find out the center of gravity or the center of rotation of the common center of rotation of these two bodies, and we need to calculate I at that point. But fortunately here both the centers are passing through the O. So then in that case it's a I is simply addition of IR plus ISD. So if you simplify this one, it becomes I equal to mr square by 2 plus this one is 4 plus 2, how much? 8 into 2, 16. So already this is mr square by 2 plus mr square by 16. This becomes 9 mr square by 16. But moment of inertia of the flywheel about its axis of rotation is expressed as alpha mr square. This is equal to alpha mr square. That means alpha equal to 9 by 16. And next problem is asked in 2014 again. From the 2014 we have multiple sets. So this is also from 2014. So let's read the problem again. So maximum fluctuation of kinetic energy in an engine has been calculated, this one. So they have given delta E. Delta E is given this one to 2600 joules, assuming that the engine runs at an average speed. Average speed is given as a 200 rpm, and the polar moment of inertia. We need to calculate polar moment of inertia to keep the speed fluctuation within the 0.5% of the average speed. So here again we need to calculate I. What is the I? So we know formula equal to delta equal I omega square Cs. So what is the Cs? So here speed fluctuation should be within the plus or minus 0.5. So whenever I say plus or minus 0.5, either we can directly multiply this 0.5 into 2. That means it becomes plus or minus 1%. 1%. If it is a plus or minus 0.5, otherwise can be called as a 1% of the mean speed. Otherwise we will again derive omega 1. What is the omega 1? This is the 1 plus 0.005 of omega, and omega 2, that is the minimum angular velocity, equal to 1 minus 0.005 into omega. So what is the omega 1 minus omega 2? That equal to 0. This one minus omega 1 minus omega 2, that is 0.01. so into omega. This means Cs equal to delta omega by omega, that is 0.01. That is what, even if you multiply the 0.5 with a 2, finally we end up with the same answer. And omega also given, average speed is 200 rpm, but it's given in the rpm, means we need to convert omega into the n, and delta E also given, again it's a direct formula, so we need to substitute this one. So what is the delta E? 2600 by Cs is 0.01 into omega, that is a 2 pi into 200 by 60 whole square. So we will get I equal to 592.728 kg air meter square, because everything we have taken in the SI system. SI system in the sense everything we have taken in the meters, and it's asked in 2014. Actually, I have been looking for this type of problems. So if you could recollect, we have solved already this type of problems in the previous sessions. So here torque and angular speed data are given in the graphical format, and we need to calculate moment of inertia I of the flywheel. So how to calculate moment of inertia? Again the same procedure. Moment of inertia equal to delta E equal to I omega square into Cs. So here we need to calculate, first we need to calculate delta E from the given figure, and it's omega 1 and omega 2 and Cs, or we can calculate I into omega 1 square minus omega 2 square. So this omega 1 and omega 2 are corresponding to the maximum angular velocity and minimum angular velocity. So that we need to see how we need to see that. And let me mark this one. This is a, this is the B, this is the point C and the point D. And here we want to calculate mean torque. So what is the mean torque? How to calculate mean torque? How to calculate mean torque? So energy in the T theta diagram equal to, what is this one? 3000 into area of this one, area of this rectangle, that is the 3000 into pi minus pi by 2, that is 1500 into pi, minus, this is in the negative direction, right? This is in the downward direction, and this area of this rectangle, that is minus 1500 into 2 pi minus pi, that is 1500 pi. That means it's a 0, that is equivalent to t mean into period p. Here in this case this period is 2 pi, this cycle is completing, our whole process is completing within the 2 pi. So that means t mean equal to 0. So here t mean equal to 0 means this line. So let me draw with some other line. So this green line, this line axis, theta axis itself is the t mean, so we have two areas. This one, this is the um, energy, surplus energy area, and this is a surplus deficit energy area. And even without going for this one, we can calculate, we know how to calculate delta E from this one. That is simply the maximum area that is varying about the Tm. But since here this is given, we need to find out, we will see how to correlate this with this one, because we have already seen in the previous session also. Here I would like to draw the same diagram here. So for example, this point A is here, this is the 10 radian per second, this is the omega axis, and this is the theta axis. I'm just reproducing the same diagram here, and this is the point B, this is the point B, this is like this, and at point C, this is increasing, speed is increasing at point 3, and by the time if you reach D point, again it's becoming 10 radian per second. This is the point D. How it's varying we will see. So for example, at the initially it is having some velocity 10 radian per second, and here there is no deficit or surplus energy, so that's why it's maintaining its constant energy until it reaches the point B. And when the crank is rotating from point B to C, it got some surplus area. That means flywheel is gaining the absorbing the energy, excess energy, in turn that is producing more velocity. So by the time the crankshaft or flywheel reaches the point C, it's gaining some velocity. So that's why C is at the higher velocity. And this is and when the crank rotation is starting from C to D, it's entering into the deficit zone. That means it's losing its velocity when compared to the point C when it reaches point D. So that's why at point D again the velocity is came down compared to the point C. And we need omega D, omega C, omega B, and omega A. So how to calculate delta E? So delta E is E1 minus E2, where E1 minus E2, where E1 is the kinetic energy corresponding to the maximum angular velocity, and U2 is the kinetic energy corresponding to the minimum angular velocity. So here we have three minimum angular velocities, that is omega A, omega B, and omega D, and we have one maximum angular velocity, that is omega C. So we can take this area, or we can take minimum angular velocity either at point A or B or D. So for example, if I take at point A, then this becomes this is my minimum velocity and this is my maximum velocity, and this is the corresponding area that I need to calculate. This is the corresponding area that gives the delta E. So delta E is in this region is the area above the mean torque, but here the area above the mean torque is only this rectangle. For example, if I consider omega B is the minimum one, again I need to consider this area as the delta E. This area is the delta E, and delta E is area above the mean torque, again that is equivalent to this rectangle. Or if I consider this as the minimum angular velocity, then I need to consider this area from here to here, this area as the delta E region, and the I mean area which is either above or below the mean axis is the delta E. So here it's a below delta E. So area of this rectangle is a delta E in this case. So we can consider all these any one of these three cases. Why? Because here omega A equal to omega B equal to omega D, that is the minimum value of the angular velocity. So let's say I am considering this one. So the area of this one gives the delta E. And what is the minimum here? What is the omega 1? Omega 1 equal to maximum, that is omega C, corresponding to omega C, that is a 20 radian per second. And what is omega 2? That equal to, either you can take any one of these one. So let's say I am taking omega B. So omega B equal to 10 radian per second. And delta E, area of this rectangle, what is the area of that one? So we already calculated delta E equal to 3000 into pi by 2, pi minus pi by 2, that is pi by 2. So that is 1500 pi. This is the delta E. So what is I? I equal to I by 2 r, I by 2 equal to delta E r 2 delta E by omega 1 square minus omega 2 square. And if I substitute these values, 2 into this delta E. Delta V we have already calculated from the above 2 T theta diagram, that is a 1500 pi by omega 1 is 20 radians and omega 2 is 10 radians, where omega 1 is a maximum angular velocity and omega 2 is minimum angular velocity. 20 square minus 10 square, and if you simplify this one, then we finally get pi kg meter square. So let me recollect what we have done in this problem. So first we need to calculate delta E. To calculate the delta E, we need to identify the maximum fluctuating area around the mean torque. So we need to calculate mean torque. So how to calculate mean torque? That we have calculated from this formula, that is energy. After calculating the mean torque, we need to identify the maximum varying area either above or below the mean torque. So that's how we have followed this one.